Hello my dear students, welcome back to NEET World. So today we will be discussing states of matter. So particularly from this chapter we can expect a 2 marks question in your final IPE exam, okay, right. And you know, so there are some around 10 questions maximum. Yes, if you follow those 10 questions you can expect one question from it, or at least a similar question to that 10 questions that we are going to discuss here for 2 marks in your final exam, okay, right. So let's start our session here with the states of matter. And you know guys, so this is our C60 material which is designed to score 60 out of 60 in your IPE exams. It will be available for both first year and second year students. Now you can access this material from our MedWorld app, okay. So download this MedWorld app from Play Store, then just message in the chat box like informing that you are a class 11 students, like mention it as 11th IPE chemistry or 11th IPE MPC, so that you can access our 3 materials. If you are an MPC students, you can get mathematics, physics as well as chemistry for free of cost, and if you are BPC students, along with physics and chemistry you can get your biology material, okay, right. So this will be available in the app itself. Yes, you can read there itself and you can make your preparation more effective and more productive, okay, right. Now in the last sessions, see this is our material. If you open it, it will be like this. So in the last sessions we have covered all these LAQ type answers, long answer type answers. Then in this there are almost most of the topics are covered here from 4 marks. Yeah, few more are there, we will be discussing them in the upcoming sessions. Now I will be discussing this one, states of matter. In the last session we have covered this stoichiometry for 4 marks, 2 marks right now, right. So let us start our discussion here. Yeah, states of matter. If you see, these are the questions you can expect in the final exam, because we have collected these by looking at the previous year papers, like previous year papers of IPE exams, then we have made this, okay, as per the blueprint. Now look at this first question, state Graham's law of diffusion, okay. So this is the first question, state Graham's law of diffusion. What is Graham's law of diffusion? It's very easy. See, in a simple word, you first remember the formula. See, in the simple way, how can you remember this? Directly go through formula direct. See, rate of diffusion is inversely proportional to square root of molar mass of that substance, okay. Like this you can remember, okay. So if you remember this formula, yes, you can even define this properly. See, at constant temperature and pressure, what is Graham's law of diffusion? At constant temperature and pressure, the rate of diffusion, okay, rate of diffusion of a gas is inversely proportional to square root of its molecular weight. So what it is? It is rate of diffusion. It means we have a gas here, okay, we have some gases here, gas A, gas B, gas C, something like this we have, okay. Out of these gases, which gas will diffuse most easily or more easier rate of diffusion, like which is having more rate of diffusion, which will undergo faster diffusion, that is what rate of diffusion means. So which will diffuse faster? It depends on their molar masses, their molecular weights. So one which is having more molecular weight, one which is very bulky, like very high molecular weight, then it will be having lower rate of diffusion, okay. It is inversely related, more molecular weight, less rate of diffusion, that's it, okay. And we know molecular weight, it means, see how the mass and density is related. See, mass and density, they are directly proportional now. How do we get this? Density equals to mass by volume we are writing now. So greater the mass, greater is the density right now. So rate of diffusion inversely proportional to square root of mass, or in the place of mass we can also write it as density, okay. So rate of diffusion is inversely proportional to square root of mass, or rate of diffusion is inversely proportional to square root of density, that's it, okay, that's it. These are the 2 relations to be remembered for Graham's law of diffusion. So now what you can say, at constant temperature and pressure, T and P are constant, at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to square root of its molecular weight, that's it. This is the formula to be remembered and you need to write it in this way, okay. And this discussion is at what? constant temperature and pressure, remember this. Okay, now I wanted to compare this mixture of gases we have now. I wanted to compare for two gases. So let us say R1 is the rate of diffusion of this gas A and R2 is the rate of diffusion of this second gas, let us say gas B. Okay, then what you can write here, see it is inversely related now, rate is inversely proportional to molar mass. Okay, molecular weight. Okay, so now I can remove this proportionality and I can write R equals to, and keeping a constant K, that is a proportionality constant, let us consider, multiplied with 1 by root M. Like this we can write. Okay, so wherever I have R1, there I can place like this now. So in the place of R1, I can write this as M1, like K by M1, K by root M1. So K by root over M1. Okay, and wherever we have R2, there we can write K by root over M2, so I can write here root over M2. Okay, that's it. These both are proportionality constant, remove them. So what we will get, R1 by R2 is equals to root M2 by root M1, that's it. This is how you need to mention root M1, that's it. Okay, so up to here it is clear. So in the place of M2 by M1, you can also write D2 by D1 as we got this relation. Okay, is this clear guys? Guys, if the discussion is clear, please click on the like button, and you can mention if there is any confusion here in understanding, please write in the chat box. I will be explaining it here. I will be re-explain the same if you want based on your response. Okay, right. Now we will be having second question here. State Dalton's law of partial pressures. So what do we mean by Dalton's law of partial pressures? See, what I am saying is, look at this. It is very easy to understand. See what I am writing here. See, I have a container. So in this container, let us say there is a gas 1, okay, gas 1 or gas 1 I am saying, gas 2, like that we have mixture of gases. Gas 1, gas 2, gas 3, like that we have different gases, let us consider. Okay, so now each gas will exert some pressure in the container. No? So the total pressure of this container, if I ask, the total pressure exerted by these gases can be taken as the partial pressures exerted by each gas. The partial pressure exerted by gas 1, partial pressure exerted by gas 2, partial pressure exerted by gas 3, like so on, the number of gases we have you need to take here. Okay, so look at here, at constant temperature and volume. So since I have taken a closed container, its volume is fixed, and this observation is done at a constant temperature, a specific temperature. Okay, if you change the temperature, partial pressure of gases also changes. That's why what I am saying, at constant temperature and volume, the total pressure exerted by the mixture of non-reacting gases is equals to partial pressures of all individual gases present in the container. See how many individual gases we have. So each gas will exert some specific amount of pressure now. So gas 1 is exerting partial pressure as P1 and gas 2 exerting P2. Like that, at constant temperature and volume, these gases are there now, they will be exerting some individual pressures. So the total pressure of the container, the total pressure of all gases here will be equals to sum of the partial pressure of the gaseous substance present here. Like this you need to take. Okay, and these gases should not react. These are non-reacting gases. They should not react with each other. Okay, they should not react with each other. Okay, for example, you should not take here HCl and ammonia. See, HCl is an HCl is a gas only, ammonia is also existing gaseous state right now at room temperature if we consider. Now HCl is an acid, ammonia is a base, so there will be acid base reaction now. So this partial pressure won't applicable for this reacting type of gases, it is applicable for only non-reacting gases. For example, here you can take N2, O2, H2. At normal temperature will they react? No, right? So it means yes, it is applicable for this non-reacting gases but not the reacting gases at that temperature. Okay, so this is what you need to mention and you need to remember during your preparation. Okay, because if you understand the concept in this way, it will be also useful for your other competitive exams like JEE, NEET and EAP set. Okay, so that's way, do not by heart the things, try to understand the concept. Okay, that's it. Next one here, if you see, a practical example is mentioned here. Just yeah, so just look at here what they are saying. The example mentioned here is, if a gaseous mixture contains oxygen, nitrogen, carbon dioxide with a partial pressure. See, what is the partial pressure of oxygen given? in the container, it is 0.5. And what is the partial pressure of N2 is given, it is 0.3, and partial pressure of carbon dioxide is given as 0.2. Now I am asking total pressure. So P total means what? You need to add partial pressure of O2 plus partial pressure of N2 partial pressure of CO2, that is 0.5 plus 0.3 plus 0.7, that is 1.0 atm. Upon adding all these things, you will get 1 atm pressure. This is the total pressure exerted by those gaseous mixture present in that container. Okay, that's it. This is how you need to understand your Dalton's law of partial pressures. Okay, then next. Here one more question we have. Yeah, so from states of matter, we can expect a direct numerical type of question, direct 2 marks question, just formula based question we will be having in the exam. See, how many times does methane diffuses faster than sulfur dioxide? So we need to answer this. How many times methane diffuses faster than sulfur dioxide? See, where do you have studied about diffusion? Rate of diffusion is inversely proportional to molar mass of molecular weight of that substance. We have discussed during Graham's law of diffusion right now. So now according to Graham's law of diffusion, so rate of diffusion is inversely proportional to square of molecular weight of that particular gaseous substance right now. Okay, so now what you can say, here we are comparing methane gas with SO2 gas right now. So you can say R of methane, that is rate of diffusion of methane by rate of diffusion of SO2 is equals to root over M2 by M1, that is molar mass molecular weight of SO2 by molecular weight of methane. You can write like this. Okay, that's it. So now what they are saying, how many times does a methane diffuse faster than sulfur dioxide? So rate of methane, diffusion of methane by rate of diffusion of SO2 is equals to root over, what is the mass of SO2 we got? S means 32 plus O2 means 32. So this is 64, right? You can write here 64. And what about methane? So methane means carbon, hydrogen. So it is 12 plus 4. So it is 16. So you can write here 16, that's it. So this will be 16 4 just 64. So root 4 means you can write 2, right? So means from here what you got? Rate of methane, rate of diffusion of methane is equals to 2 times of rate of diffusion of SO2. So how many times greater? The rate of diffusion of methane is 2 times more than the rate of diffusion of sulfur dioxide. That's it. So this is how you need to answer. See guys, the same question whatever you have studied here, see this is equally important for your EAP set exam also. Why it is equally important? Yeah, so why only I am mentioning EAP set? Because this syllabus is not in the part of your JEE mains and NEET exams, okay, when it comes to chemistry part. But yes, you can expect these questions in your physics again, okay, because yes, you have this type of concepts in your physics, right? So you can expect this kind of questions in your physics, but in EAP set, yes, you can expect this question in the chemistry part itself. Okay, yeah, the question discussion is clear, right? Let us move forward. Yeah, so this is how we have solved. Everything is mentioned in the material. You just download this from our MedWorld app for free of cost and make your preparation. Okay, right. The next question here, what is root mean speed? What is root mean speed here? What is root mean speed? Yeah, so before coming to this root mean speed or root mean velocity, like we will be studying the other one later, will come here. Okay, just a minute. So root mean square velocity will be studied later. First of all, let us finish this. Average speed. What is average speed? See, average speed means, see, we know average means what we will be doing, like number of, like sum of observations by number of observations we will be writing now. So in the same space, in the same way, see, there is a container. Here we have different gases like gas 1, gas 2, gas 3, like that we have different number of gases. Now the average speed of these gases, see, each gas particles in this container will exert some individual velocities, right? Okay, the average speed of gases is the total, the average speed of a gas is the total of all molecular speeds divided by total number of molecules here. So it means these gaseous particles are exhibiting velocities like u1, u2, u3 like this. Okay, so you can add all those speeds divided by number of that gaseous particles here. It represents the mean value of speeds of all gas molecules in the sample. So let us say gas particles are moving with u1 velocity and some are moving with u2 velocity, some are moving with u3 velocity, like that different speeds or different velocities are there. So you take total number of that gas particles, sum in the numerator and divide with the number of those gas particles here, that's it. Okay, so it represents a mean value of speeds of all gaseous molecules in the sample. Okay, that's it. So this is called U average. Okay, yeah. So you can see u1, u2, u3 so on is called individual speeds of gas molecules. Okay, and where here n represents total number of gas molecules, and yeah, so up to here we got some clarity on the formula. Okay, so now next formula is we have direct relation that U average velocity is equals to root over 8 RT by m, 8 RT by pi m, 8 RT by pi m. So guys, again remember, based on this U average, U RMS, U MP, U most probable means most probable velocity. So based on these three terms, you can directly expect a question either in the physics or in the chemistry part. Okay, whether it can be, mostly it will be in EAP set. If not in EAP set, yes, you can also see in your physics syllabus of JEE NEET also. Okay, because states of matter is there in your physics part also, right? That's why. Okay, so what is the formula? Root over 8 RT by pi m. Remember this, root over 8 RT by pi m, that is U average. Okay, now next one is most probable velocity. What do we mean by most probable? See, most probable, it means there is a speed exerted by most number of molecules, that is considered to be most probable velocity. See here, the speed possessed by maximum number of gas molecules in a given sample of gas is called most probable speed. So what I am saying, if you take a container having gas particles here, all these gas particles are there. So here maximum number of gas particles are having a particular speed. So maximum number of gas particles are having some specific amount of speed now. So that speed is called most probable speed. So you can see the speed possessed by maximum number. See, maximum number of molecules will possess a particular speed. Okay, particular value of speed. So that is considered to be most probable speed. The speed possessed by maximum number of gas particles in a sample of gas is called most probable speed. Okay, you can write this as UMP, that is most probable speed will be equals to, or most probable velocity is equals to root over 2 RT by m, 2 RT by m, that's it. That's it. This is what you need to remember here. Okay, and the next one here is URMS. URMS, what do we mean by URMS? We will see here. See, you got this U average now. So similar to this, see here, read this. The root mean square velocity or root mean square speed of a gas is a square root of, so it's a square root of the mean of like number of observations is, total number of observations are n. The mean means average only now. The mean of squares of speeds of all gas molecules. See, if there is a gas particles with u1 speed, you take it the square of that u1. Okay, and there are some gas particle with u2 speed, take square of that. Okay, and u3 speed, take square of that. Okay, and u4 speed, take square of that, like that, so on you take by total number of molecules we have, like this. Okay, so this is what we can say URMS, you can say. Okay, yeah, up to here the formula is clear, right? And the next one is, there is a relation between temperature and URMS. These three relations, whatever you have studied, root over 8 RT by pi m, this is for U average. Okay, and root over 2 RT by m, this is for UMP. okay, and for URMS, root over URMS is equals to root over 3RT by M. So these are the three relations you must remember, okay. It will be equally important for your competitive exams along with your IPE exam. Please try to remember these three formulas, okay. How do they related to temperature and molar masses, you need to remember. See, greater the molar mass, lower is the velocity. So more bulky or more mass it has, lower the velocity they show, okay, whether it can be URMS, U average or UMP, okay, that's it. Okay, is this clear? And you know, when you are calculating, temperature should be expressed in Kelvin, okay, temperature should be in Kelvin, okay. And why? Because the R value here we know we are calculating in terms of Kelvins only now. Yes, you need to take temperature also in Kelvins, okay. What is the universal gas constant R value here you can take? So if it is in kilojoules, you can take 8.314 joule Kelvin inverse mole inverse. Okay, if it is in calories, you can take 2 calorie per Kelvin per mole, and an average value you can take 2 calorie per Kelvin per mole. Okay, these values to be remembered for R. Okay, that's it. Next here we'll be explaining few more things. Yeah, this is done. So look at this 7th question here. Why is pressure cooker used for cooking food on hills? Okay, let me check this. Yeah, so what they are saying, why is pressure cooker used for cooking food on hills? Okay, so when you go for hilly region, so they are specifying that pressure cooker is used. So but why it is used in the hilly areas? This is the question they are asking. So when you go for hills, hilly areas, what happens is their atmospheric pressure is low when you compare with the sea level. See, at normal sea level, the atmospheric pressure will be more when you compare with the hilly areas, okay. So lower atmospheric pressure, na, see, at higher altitudes, so at high altitudes the atmospheric pressure is low. So if pressure is low, the boiling point of that liquid, see, for example, we are cooking rice, okay. So for cooking this rice, we will be first, what we will be doing, we will be boiling the water right now. So we will be taking here water first, okay, and we will boil the water, then we will be adding this rice, whatever the raw rice we are taking, so that rice will be added. So now it will be boiled out, okay, we will be heating it, it will be boiled out. But we know the temperature, the boiling point of water is 100 degrees Celsius right now. So this is 100 degrees Celsius at what conditions? This is at normal sea level, but we are at high altitude range now. So at high altitude range, due to lower atmospheric pressure, the boiling point of water also decreases by some value. So when it is decreasing by some value, what happens? The water will boil easily and get evaporated before cooking this rice, before cooking this food. So that's why we cannot cook it normal ways. So if we use the pressure cooker, what happens? If we use this pressure cooker, let us say this is a pressure cooker. Now what happens? So this pressure cooker, whatever the water converted, see, water will convert into steam now. So it will not allow the steam to get evaporated here. So it will be closed so that it will increases the pressure inside this cooker. So when it is increases pressure inside the cooker, so the boiling point of temperature will be rises again, okay, to the normal conditions, and rice will be, or whatever the food we are taking, that will be cooked properly. So that is the importance of pressure cooker at the hilly region. See, at high altitudes the atmospheric pressure is low, hence liquids boil at lower temperature than at the sea level. Therefore this, whatever the liquid, for example water, if we take, that will goes out, okay, easily evaporates out at this lower lower atmospheric pressures at high altitudes. Okay, so that's why it is important to be used this pressure cooker. Therefore, a pressure cooker is used to cook the food by increasing the boiling point of water. Why it is increasing the boiling point? So when the pressure cooker, the steam is produced here in the cooker now, when we heat it, so that will be increasing the pressure inside this cooker vessel right now. So when it is increasing the pressure, now what happens, the water molecules will come closer, so their boiling point will be elevated. Okay, this is what you need to remember. Okay, up to here it is clear. In the next question you can see here, yes, this is also most repeatedly asked, a numerical based question based on RMS velocity. So how can you solve this? See, calculate the RMS velocity of CO2 gas molecule at 27 degrees Celsius. So first of all, convert this 27 degrees Celsius to temperature in Kelvin. Okay, then you can do your question. Okay, so RMS, what is the RMS velocity? Formula U RMS, what is the relation with the temperature and molar mass of that gas? U RMS is equals to root over 3 RT by M. 3 RT by M. So temperature is given as 27 now. So 273 plus 27 you can take. Okay, this will be 300 Kelvin. So you got temperature as 300 Kelvin. What is the molar mass of CO2? It is 44. It is 44. Okay, so now look at here what they are explaining in this case. U RMS is equals to root over 3 RT by M. So now if you simplify, what is R here? You can take this value as 8.314 joules Kelvin inverse mole inverse, like that you can take. Okay, upon simplifying, but upon substituting the values over here and simplifying, you will get a relation something like this. U RMS is equals to 1.58 multiplied with 10 power 4 root over T by M. So where T is temperature in Kelvin and M is the mass, that molecular weight of the substance. So the answer will be in centimeter per second. Okay, so velocity, right? So here it is in centimeter per second, speed. Okay, so 1.58 into 10 power 4 root over 300 Kelvin, yes, 300 by mass is 44. Yeah, upon simplifying you will get 4.125 into 10 power 4 centimeter per second. So this will be the answer for the question. In the same way you can do it for kinetic energy. So what is the relation between kinetic energy and temperature? See, kinetic energy will be taken as average kinetic energy is equals to K is equals to 3 by 2 RT for 1 mole of a gas. So how many moles they are saying? Kinetic energy of 3 moles. Then you can take it as nRT, that's it. So average kinetic energy is equals to 3 by 2 nRT. So here you can say 3 by 2 n. How many moles given? 3 into, what about R value they have mentioned? So they won't mention, we need to take it as 8.314 Kelvin inverse mole inverse, like that. Okay, so if you want to calculate in joules, you can take it in 8.314. If you want to calculate in calories, you can take R value as 2 calorie per Kelvin per mole. Okay, multiplied with temperature. 27 degrees means it is 300 Kelvin, right? So you can remove this. Upon simplifying this, you are going to get 27, 3 3 is a 9, 9 3 is a 27. So 2700, okay, and the value will be in calories, energy will be in calories. So this is what the value will get. Okay, so if they ask for kilocalorie, you can write 2.7 kilocalorie. This is the kinetic energy of this CO2 gas molecules at 27 degrees. Okay, that's it. Okay, so in the similar way, they may also ask you to calculate kinetic energy of 5 moles of nitrogen gas. Will you do this? Yes, take it as a homework and tell me what will be the answer for this. Without seeing this answer, try to practice once and just tell me whether you are clear with this concept or not. See, kinetic energy means what is the formula we can use? See, 5 moles is given, so N and R at some specific temperature is mentioned, that's it. N into R into T you take. So N represents number of moles, that is 5 multiplied with R and multiply with the temperature. Yes, here in this book, in this module, I have specified the value. I got the answer in terms of calories. 4500 is a calorie. Now I want the same answer, same data will be provided, but I want your kinetic energy value in terms of joules, okay, in terms of kilojoule per kilojoules I want. What will be the answer of this kinetic energy of this N2 gas at 27 degrees in kilojoules? If you get the answer, please mention the answer in the chat box. I will be looking into it. If it is correct, it's really good. If not, I will explain, no worries, but give a try and tell me your answer in the chat box. It's very easy. What's the R value you should use here? 8.314 joule Kelvin inverse mole inverse you use, and tell me what will be the answer in the chat box. Okay, so thanks for watching. Okay, then next we will be seeing if there is any question from this discussion, we will continue. Yeah, one last question here we have is 11th question I am showing you here. What is a surface tension? So what is surface tension? See here, the force acting per unit length. So force acting per unit length acting perpendicular to the line drawn on the surface area of liquid. See what actually surface area, where do we see? See, water droplets seems to be spherical in shape. Right now, why they are in that shape? Because due to the cohesive forces between the water molecules, between the droplets of this water, I mean the water H2O molecules, there will be cohesive forces like attractive forces. Due to that attractive forces, they will come closer. So due to that reason only, water molecule like droplets will be spherical in shape. And if you take the water in any container, how you will be seeing it? So you will be seeing that water will be somewhat like the meniscus will be somewhat like this right now. So lower meniscus, upper meniscus we are saying, no. So all these are due to the cohesive forces. Okay, now what happens here? See, the force acting per unit length acting perpendicular to the line drawn on the surface of the liquid is called surface tension. Now surface tension formula is given as F by L, T is equals to F by L. Okay, that's it. Okay, or tau equals to F by L. Okay, so this is what you need to remember, the 11 questions from states of matter. Okay, most of the cases, yeah, question comes from here itself. Okay, and if you want me to cover anything extra from this chapter, please let me know in the chat box. We will definitely add them in the upcoming sessions. Okay, so thanks for watching. Stay connected with our NEET World channel. And guys, you know, we are also conducting EAP set free live sessions. Okay, you can join them in our live discussions daily in this YouTube channel, in this our NEET World YouTube channel itself. Yes, you can make your preparation more effective and more productive, whether it can be your upcoming NEET, JEE or EAP set exams. Yes, we are conducting free live sessions where we will be clearly discuss each and every important topic and questions related to those topics clearly explained. And if you have any doubts, you can share those doubts using our Telegram channel or the WhatsApp number which is given in the description box. You can share them and our team will guide you the further, or they will connect it to us and we will guide you further. Okay, so thanks for watching. Stay connected with our NEET World channel. Thank you.